Welcome to another session in our series of tutorials in both math and English. Today will be another math session, and I'm very excited to share with you a topic that you will find very, very helpful. What is math without solving equations? It's not math. Math involves problem solving. So today we'll start to explore what it means to solve equations. So today we'll be solving linear equations. Remember, we talked about different types of polynomials, different types of algebraic expressions. And one of the simplest algebraic expressions is a linear, which means that it has a degree of 1, as compared to a quadratic, which is a degree of 2, cubic, degree of 3. So we're going to go with simple ones to start, and then we will graduate. We'll get into higher level solutions. So let's get started. What does it mean to solve? What it means is that you're given an equation with an unknown, and you're asked to find a value that works perfectly so that what is on the left side is equal to what's on the right side of your equation. The best way to explain it is to use an example. So let's start. Suppose we had if you were asked to solve, say for example, x plus 4 equal to 15. Something plus 4 is equal to 15. And basically what they're saying is, what is x equal to so that what's on the left is equal to what's on the right. I always use this example when I teach introduction to solving. I think of a seesaw. In order for it to stay balanced, the same amount of weight on the left has to be on the right. The moment you shift the weight, then it's no longer balanced, it's no longer horizontal. So it's the same thing here. What we're saying is that the right side is 15, so the left side has to be 15 also. So therefore, we need to find out what value of x would make the equation balance, would make the equation actually truthful. Well, we need to get x by itself. So in order to get x by itself, we need to get rid of the positive 4. Yes, you might say, oh, that's so simplistic. But again, this is the concept that will drive us into the more complicated questions. So we need to get rid of the 4. How do we get rid of the 4? And the rule in math is to get rid of something, you do the opposite. Oh, what is the opposite of addition? It is subtraction. What is the opposite of multiplication? It is division. So that's the idea. If you want to get rid of something, you do the opposite. But watch this. Whatever you do to one side, you must do the same thing to the other side in order for the equation to remain balanced. If you shift and you don't do the same to the other side, it will no longer be balanced. It will be a shift. It will no longer be horizontal. So we subtract 4 and we end up with 4 take away 4 is 0. So what is left on the left-hand side? This is the left-hand side, is x. 15 take away 4 is 11. And I propose to you that 11 is the value of x that satisfies that equation. Let's check. 11 plus 4, 15. So 11 is really correct because we have 15 on the left, 15 on the right, so it is balanced. Let's try another one. If I had, say, 2y minus 3 equal to 5. and I ask you, what is y equal to? We say, okay, on the right is 5. On the left, we have 2y and -3. I need to ask myself this question. What must I get rid of so that I can have y all by itself? What can I eliminate so that I end up with y alone on the left side? Okay, in order to get y by itself, I have to get rid of the -3. And I also have to get rid of the 2. So I have two things I have to get rid of, the -3 and the +2. Okay? So let's go step by step. Let's get rid of the -3 first. I have a suggestion. What is the rule of thumb when solving an equation if I have to do multiple things to get to my solution? What you do is, whatever is further away from your variable, that goes first. I'll give you an example. I have on a jacket, I have on a shirt, and I have on a t-shirt. When I'm home and I'm ready to get undressed, what is further away from my skin has to go first. So if I had on a winter jacket, that winter jacket would have to go first, then my jacket would have to go next, then my shirt, then my t-shirt. So whatever is further away has to go first, has to disappear first. So the -3 and the +2. The +2 is multiplying the y, so it's very close. The -3 is at a distance, so -3 goes first. So here we go. Add 3 to both sides, and we end up with 2y equal to 8. And now we need to get y by itself. We need to get rid of the 2. So the 2 and the y, there's no operation indicated. And in math world, if you don't see an operation between two things, it means that you're doing a multiplication. This means 2 times y. That's what 2y means. 2 multiplied by y. So to get rid of the 2, here we are multiplying by 2. So to get rid of the 2, we have to divide. So we go, divide both sides by 2, divide both sides by 2, and finally, we end up with 2 cancels 2, we end up with y equal to 4. So the answer to this question is y is equal to 4. Let's find out if that's really true. We do that by plugging in the value we created and see if it works. 2 times 4 is 8. Take away 3, 5. Perfect. Okay, so we have 2 questions down. Let's see if we could do something more involved. I'm going to leave my seesaw over there to show the balance. Okay, so let's try this one, number 3. Suppose we had, say, for example, 4 times 5 minus 3x equal to, Okay, what should we use? Okay. Let's try something. Let's go for 40. Oh, let's go. Let's go for 68. Let's try a big number. Big number. What do we have? 4 parentheses 5 minus 3x equal to 68. Look at where we started. We started at x plus something equal to something. Now we have more stuff going on. We have a lot of stuff going on. What must we get rid of in order to get x by itself? What are the things that must go in order for us to have x by itself? Well, if you're looking, you will see that the 4 has to go. The parentheses have to go. The 5 has to go. and the -3 has to go. So we have the 4, the parentheses, the 5, and the -3. All of those things have to go so that you end up with x by itself. What is the further away from x? The 4 is on the outside. It's outside looking in. So that's the further, the one that's farthest away. So we divide both sides by 4. And what do we get? Divide this side by 4, we end up with 5 minus 3x equal to 4 into this gives me 17. Oh, by the way, as I have said before, there isn't just one way to do your math problem. I could have multiplied this out first and then solve it. You know what? We'll do that also to show you that it still works another way. So let's finish using this method. We need to get rid of the 5. So it's positive 5. So to get rid of the positive 5, we need to subtract 5. 5 take away 5 is 0. So we're left with -3x. 17 take away 5 is 12. So -3x is 12. So now this is -3 times x. So we're doing a multiplication. Don't get confused with this -3. It's -3 is a number. The number has a negative sign, and you're multiplying the -3 times the x. So to get rid of the -3, we have to divide by -3. -3 divided by -3. Anything divided by itself is 1 except 0. 0 divided by 0 is undefined. There's no value for that. It doesn't exist. Okay? So now we end up with x equal to positive 12 divided by -3. You remember when we did negative and positive numbers? We said that if the signs are different and you're dividing or multiplying, the result is going to be a negative. But if the signs are the same, when you divide or you multiply, the result is positive. So the answer is going to be negative, and 12 divided by 3 is 4. So I had mentioned to you that we could have done the same question another way by getting rid of the parentheses and then afterward doing. So let's try that and see if it works. I don't like that method, but I'll still do it. So let's multiply, we use the word distribute. We're going to multiply everything inside by 4 because it's 4 times all of what's in the parentheses. 4 times 5 is 20. 4 times -3x is -12x. And of course, you're only multiplying what's on the left side. The 4 does not affect the 68. The 68 is on the other side. So we end up with 6, 8. So now we need to get x by itself. We could subtract 20 from both sides. It's positive 20, so we're going to subtract 20 from both sides. This cancels, so we're left with -12x equal to 68 take away 20 gives me 48. So now -12x is 48. We need to get rid of the -12. Again, it's -12 times x. -12 times x, -12x. So we need to divide by -12. And we end up with x equal to positive divided by negative is a negative answer. And 48 divided by 12 is 4. See, x equal to -4, x equal to -4. Same answer. Now, somebody will say to me, oh, let's check to see if it's correct. Let's check to see if our answer is correct. We go back and plug in the -4 where we see x and see if the left side turns out to be 68. So we're going to work on the left side and see if we get 68. If it's correct, then this should be 68. Let's go. So it's 4 times We're going to need another set of parentheses. So let's go with the hierarchy. So it's 4. Let's use a square bracket. 5 minus 3 times x, which is -4. Remember I said if you're using parentheses inside of parentheses, then use 2 different types to differentiate. Okay? If x is a -4, so it's good to put it in parentheses so that you don't make a mistake. So now we have 4 times 5, -3 times -4 is +12. Negative times negative is positive. If the signs are the same, the product is positive. If the signs are the same, then when you divide, the quotient is positive. So here you go, 5 plus 12 is 17. So it's 4 times 17. And 4 times 17 is equal to 68. So I had to do the number in my head so that the numbers came out nicely. So there it is. So we prove that -4 is actually correct. So it's starting to look like we're doing some more difficult questions, don't you? Don't you know that way? We have more to go. Let's go. Okay. Let's try number 4. X over 3 plus 4 equal to 5. Okay. So what do? According to this, we need to get rid of the 4. We need to get rid of the 3. Many people, whenever they see a fraction, they get very nervous. I don't know why. Fractions, we have the power to get rid of fractions, to handle fractions if we're not scared. If we're not scared, we're good. But it's when we get scared, we're crippled. So let's watch what happens right now. Let's get rid of the 4. So we have x, subtract 4 from both sides, subtract 4. So now x over 3 is equal to 5 take away 4 is 1. So look at this. We're dividing by 3. How do we get rid of the 3? We have to multiply. We have to multiply by 3. That's how you get. You do the opposite. So instead of dividing by 3, you multiply both sides. You can't do one side, otherwise it's going to be unbalanced. We have to do both sides by 3, and that's how you fix that problem. So 3 times x over 3, 3 multiplying, 3 dividing, they cancel, is equal to 3 times 1. So the 3 here cancels that. We end up with x equal to 3 ones, 3. And that would be our answer. So far, all the questions we have done, we have the variables on only one side of our equation. Let's mix it up a little bit. Number 5. So number 5. We have 2x minus 8 plus 5x minus 3 equal to equal to 15 minus 3x. Whoa, look at that. Quite a few things happening here. And your job is to solve. Your job is to find what value of x would make this correct. What number for x would make this left-hand side equal to right-hand side? Are you ready? Are you game? I am. Let's go. Let's go. In a previous class, we talked about like terms. We said that whenever you have like terms, you could add them together and you could subtract. If they're different, you can't add and subtract. So let's look and see what are the like terms. The x's are like terms, and the constants are like terms. So you can put the constants together, and you can put the terms with x's together, because they're all at the same power, 1, 1, and 1. So let's fix the left-hand side first. So 2x plus 5x is 7x. Negative 8 minus 3 is negative 11. And that's equal to 15 minus 3x. So now, could we get rid of the negative 11? We get rid of the negative 11 by adding 11 to both sides. So we end up with plus 11, and we end up with 7x equal to 26 minus 3x. Wouldn't it be nice to get this negative 3x over to the other side? In other words, get rid of it from the right side and get it on the left. The way you do it, you do the opposite. You add 3x, it cancels over there, but you also have to add 3x to the left. So when we add, so now we end up with 10x equals to 26. See? Now we just need to get rid of the 10 and we're good to go. How do we get rid of the 10? We divide both sides by 10 because this is 10 times x. Divide both sides by 10, we end up with x equals to 26 over 10. And if you remember when we did fractions, 26 over 10 can be simplified. You can divide the top and the bottom by a number that will make it into a smaller fraction. So look at this, or a reduced fraction. If you divide by 2, we get 13. Divide by 2, we get 5. So the answer is x equal to 13 over 5. That's the final answer. So what did you notice just now? You could end up with a fraction as your answer. I don't like to do decimals, so let's leave it as 13 over 5. That's fine in math world. That is beautiful. You don't have to stress over it. Okay? So let's try another one. So from when we started to now, see how ugly it gets very fast? Or more complicated it gets very quickly. But we can do it. Okay, let's go. Let's try this, number 6. I'm gonna just do some crazy stuff on the board and let's see what happens. So if we have 4 times 2x minus 8 minus 5 times 3x plus 1 plus 4 equal to 2 times 7 minus 6x. I'm just writing something crazy. Is that long enough? Is that long enough for you? Wow. Wow. When we just started, we had something plus something equal to something. Look at this now. Lots of ugly stuff happening here. But we can do this. We are problem solvers. We can find the x that works for this question. Don't be surprised if it is a fraction, okay? How do we go about doing this? I suggest that the first thing you do is to distribute, get rid of all the parentheses, then combine like terms. And let's see what happens. 4 times 2x, 8x. 4 times negative 8, negative 32. Negative 5 times 3x, negative 15x. Negative 5 times 1, negative 5. Plus 4 equal, on the right side, 2 times 7, 14. 2 times negative 6x, negative 12x. No more parentheses. But if I look here, I see 8x, negative 15x. I can combine these two, and I can also combine negative 32, negative 5, and positive 4. Let's see what we get. 8x take away 15x is negative 7x. Negative 32 minus 5 is negative 37. Plus 4 is negative 33. Now we need to get all the x's on one side and all the constants on the other side. So let's get rid of the 33. Add 33 to both sides. We get negative 7x equal to 47 minus 12x. Now we need to get all the x's on one side. So this is a minus 12x. Why not add 12x to both sides? So add 12x. Add 12x. I hope you notice that everything we do to the left, we do it to the right. That's how you keep it balanced. So negative 7 plus 12 gives me positive 5x equal to, this cancels that, I get 47. And all I have to do now is to get x by itself, I divide both sides by 5. That gives me x equal to 47 divided by 5. Let's go over it again. Let's see what we did. We have a binomial times a number minus a number times a binomial plus a constant equal to a number times another binomial. What did we do? We distributed, we multiplied out all the equations. So we end up with 4 times all the binomials. We distributed 4 times 2x, 8x, 4 times negative 8, negative 32. Then we distributed negative 5 times 3x, negative 15x. Negative 5 times positive 1, negative 5. The 4 is not multiplied because it's not in the parentheses. It's all by itself. So it's all by itself. 2 times 7, 14. 2 times negative 6x, negative 12x. And then we combine like terms. 8x minus 15x, negative 7x. Negative 32 minus 5, negative 37. Plus 4, negative 33. Equal to 14 minus 12x. Now we need to get rid of the negative 33. We add 33. So this cancels. We end up with negative 7x equal to 47 minus 12x. Then we want to get the negative 12x. We want to cancel it from the right. In order to cancel it, we must do the opposite. We must add 12x. And we add 12x to both sides. That's 0. And this is negative 7 plus 12 gives me positive 5. And this is 47. And then 5x is 47. Divide by 5. x equal to 47 over 5. Okay? By the way, linear equations give you only one answer. If it's a linear equation, you get one answer only. Later on, when we do quadratic equation, that is degree 2. So you have something squared, something to the power of 2, you must get 2 answers. Now, when we also do cubic equations to the power of 3, you must get 3 solutions. Keep in mind that the 3 solutions do not always have to be 3 different solutions, because in some cases you will have identical solutions. Keep that in mind. Just put that on the shelf and keep that in mind. We'll get there. So linear gives you a line. When you graph it, it's a line and it only has one solution. It only cuts the x-axis in one place. If it does. Okay. What happens if you have a question like this? This is number, I guess, 7. I don't remember. I've lost count. Suppose we have something crazy like this. Y over 5 plus y over 2 minus 2y over 3 equal to 2. How do you solve that? That's ugly. A fraction plus a fraction minus a fraction equal to a whole number. A lot of students would say, I can't do this. But I'm telling you that you can, because you have the power. You have the power to get rid of the things that you don't like. What is it that most students don't like? Fractions. They don't like to see the fractions. So here's the key. If you don't like the fractions, get rid of the fractions. How do you get rid of the fractions? I'm so glad you asked. If you multiply by the common denominator, then the fractions will disappear. As a matter of fact, we are not going to do common denominators today. But what I'm going to show you is a way that you can do it without even knowing what the common denominator is. For example, we want to get rid of the 5. So what we'll do is we have to multiply everything by 5. Multiply the left by 5, multiply the right by 5. So we end up with 5 times y over 5 plus y over 2 minus 2y over 3 equals to, we have to also multiply the right side by 5. We have to multiply the left by 5 and the right by 5. So what am I going to be doing? You should see, I'm going to multiply by 5, then I'm going to multiply by 2, and then I'm going to multiply by 3. And I want to let you know that if I knew the common denominator and I multiply by the common denominator, it would get rid of all 3 fractions in one step. Ha! But pretend that you don't know how to find the common denominator. Let's go ahead and do it step by step. So 5 times this is 5y over 5 is just y. And 5 times this gives me plus 5y over 2 minus 5 times this gives me 10y over 3 equal to 10. 5 times 2 is 10. Now I'm going to multiply everything by 2. And in the interest of space, I'm going to go ahead and multiply everything by 2. 2 times y, 2y. 2 times 5y over 2 is 10y over 2, gives me just 5y. Minus 2 times this gives me 20y over 3. 2 times 10, 20. So now I have just one fraction leave, I'm going to multiply everything by 3, and look what happens. 3 times 2y, 6y. 3 times 5y, 15y. 3 times this gives me negative 60 over 3 gives me negative 20y. 3 times that gives me 60. And now combine the like terms. 6 plus 15, 21. 21 take away 20, just 1y. So y is equal to 60. Is that correct? Let's see if it is correct. Let's check it if it's correct. 60 divided by 5 is 12. Plus 60 divided by 2 is 30. Minus 2 times 60 is 120. Divided by 3 is 40. What is this equal to? 12 plus 30 is 42. Take away 40 equals to 2. So the left-hand side is 2. The right-hand side is, it's 2. There it is. Okay, so it works. Did you remember I mentioned to you that if we knew the common denominator, we could have done the question quicker? Watch this. I don't remember if I told you how to find the common denominator of 5, 2, and 3. What I did tell you is that if you multiply these numbers all together, that is a common denominator. It might not be the least common multiple, but it is a common denominator. What is 5 times 2? 10. What is 3 times 10? 30. So I'm going to multiply both sides by 30. Look what happens. 30 times y over 5 plus y over 2 minus 2y over 3 is going to be equal to 30 times 2. What have I done? I'm multiplying the left by 30 and the right by 30. Where did the 30 come from? 5 times 2, 10. 10 times 3, 30. Look what happens. 30 times y over 5 is 30y over 5. 30 divided by 5 is 6y. 30 times y is 30y divided by 2, 15y. Minus 30 times 2 is 60. Divided by 3 is 20. Six plus 15, 21. Take away 20 is just 1. Wow. There it is. There it is. So now that you see what we're doing, let's do one more with the fractions, and then we'll transition over to zero product property. So this is the last one, number 8. Solve x over 4 minus 3x over 2 plus x over 3 minus 1 equal to 6. I don't know. Let's see what happens here. Let's start by getting rid of the negative 1 here. So we add 1 to both sides, and we get 7. So x over 4 minus 3x over 2 plus x over 3 equal to 7. What is the common denominator for 4, 2, and 3? What is the smallest number that 4 can go into, 2 can go into, and 3 can go into without a remainder? The answer is 12. I promise you that if you did not know that the smallest common denominator is 12, and you went ahead and multiplied 4 2s 8, 8 times 3, 24, and if you use 24, it will still work. You will still get the right answer. It's just that at the end, you'd have to simplify. But if you use 12, which is the smallest number you need, then you will have less steps to do the work. You won't have one additional step at the end. That's all. Okay? So if you have some experience and you can find the lowest common multiple, then there it is. But if you don't, just multiply them and then use that as your multiplier for both sides of your equation. Don't forget that. Okay. So I'm going to use 12. So it's 12 times x over 4 minus 3x over 2 plus x over 3 equals to 12 times 7. What do we end up with? Well, let's get rid of the fractions now. 12 times x is 12x divided by 4 gives me 3x. 12 times 3 is 36, divided by 2 is 18. 12 times x is 12x, divided by 3 is 4x. 12 times 7 is 84. Let's combine. 3x plus 4x is 7x. 7x take away 18x is negative 11x. So therefore, to get x by itself, you need to divide both sides by negative 11. You end up with x equal to negative 84. I just put the negative on top because what you have is 84 divided by negative 11. A positive divided by a negative, the answer is negative. It's a negative number. So I just put the negative number here. It's the same thing as 84 over negative 11, but negative 84 over 11 is what normally is used. Okay? And that will be the answer for that question. So now I'm going to go into a very neat concept, the zero product property. Let's go. Okay. This is not a complicated concept, but it's so important. It has such far-reaching effect, even all the way up to calculus. Very simple concept, but has a lot of application. What does it say? All it says is that if you multiply two things and the result is 0, then at least one of them must be 0. What do I mean by that? If A times B equal to 0, if something times something is equal to 0, then A is equal to 0 or B is equal to 0. One of them has to be 0. That's the only way you could multiply and get 0. That's it. That's all. Zero product. When you multiply, it's called a product. And you're saying that when you get the product and it's equal to 0, that's why it's zero product. See the connection? Zero product property. In order for that to be true, in order for this times this to be 0, then it's either A is 0 or B is 0. Got it? That's it. Let's do some examples. For x equal to 0. Look at this. 4 times x is 0. Think about it. 4 cannot be 0 because 4 is a number that's not 0. 4 is 4. So therefore, x has to be 0. That's all. X is 0. And how can I prove that x is 0? Divide both sides by 4. And we end up with 4 cancels 4. We end up with x equal to 0 divided by 4 is 0. But the zero product property tells you straight off the top that x is 0 because 4 cannot be 0. Okay? What about this? Look what's happening here. Something times something, that's a multiplication. Something times something equal to 0. Can I tell you a secret? A lot of students see this and right away they want to multiply this out and create a worse problem than just looking at it and using the zero product property saying this is 0 or that is 0. And then the problem is solved. Let me go again. I give this question and a lot of students try to expand, multiply, boom, 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 and all of that multiplication, and then they get confused. Whereas if they remember the zero product property, this is saying this is a product, this multiplied by that gets 0, so therefore x plus 2 must be 0 or x minus 5 must be 0, and you solve each by itself. So you could say this implies, this symbol is red, this implies that x plus 2 is equal to 0 or x minus 5 is equal to 0. One of these two must be correct. In order for x plus 2 be 0, then x has to be equal to negative 2. We subtract 2 from both sides. So x is negative 2, or from this part, add 5 to both sides, x is equal to 5. So this question gives you two answers, negative 2 or positive 5. Zero product property. Let's try another one. Okay, now you see where it's going. If I give students this without discussing the zero product property, without telling them about the zero product property, Many of my students have gone ahead and tried to multiply these three binomials. Guess what? When they do that, they get a cubic expression, more like a cubic polynomial, and then they're stuck. They don't know what to do. They're confused. But if they remember the zero product property, they could actually do it without any sweat. Because what does the zero product property say? In order for you to multiply these things together and get zero, each part, each factor has to be equal to zero. At least one of the factors must be zero. So what do? You put, well, 6, you're multiplying by 6, but 6 cannot be zero. So therefore you can ignore the 6. Or you could say divide both sides by 6 and the 6 disappears. These are the things that you look at. X plus 3 equal to 0. X minus 7 equal to 0. And 2x plus 5 equal to 0. Put this equal to 0, solve it. Put that equal to 0, solve it. Put that equal to 0, solve it. And there you get your 3 equations. Wow. Yes, that's what you do. Let's go. It implies that x plus 3 equal to 0. We end up with x equal to negative 3. Or x minus 7 equal to 0 gives me x equal to 7. Look how easy, like no sweat. Look at that. Or for this one, 2x plus 5 equal to 0. So we subtract 5 from both sides. We end up with 2x equal to negative 5. 0 take away 5 is negative 5. And then get rid of the 2 by dividing both sides by 2. X equal to negative 5 over 2. Take a look at this. X plus 3, the result is negative 3. Just change the sign. Negative 7, change the sign, positive 7. This one now, 2x plus 5, change the sign to negative and divide this by 2, 5 over 2. And that's it. Okay? Beautiful. So you never thought you'd be able to do this, but look what you've done. You have become mathematicians, now solving complex equations. This is not a linear equation. Linear was what we did earlier. This is actually a cubic equation. You have just solved a cubic equation to the power of 3. Degree 3, cubic, wow. And it's a cubic polynomial. If you expand this out, you're going to end up with 4 terms. And remember, we said that after you go 3 terms, trinomial, you start calling it polynomial. So it will be a polynomial with 4 terms, a cubic polynomial with 4 terms. You're solving that today. Wow. Amazing. I'm going to try and trick you now. Watch this. So for a lot of you who are saying that the math was so easy, Mr. Dunkley is doing some easy stuff. Now you see it's starting to get a little shady. But stay with me. I will not let you drown. I will send you something to give you a life. I'll send you a lifeguard. Okay? Number 4. So we're solving. Okay, 5x times 3 If I ask you how many solutions does that have, what would your answer be? How many solutions? Well, you have to think carefully. How many parts do we have? When you answer that question, you'll be able to answer how many solutions. First thing first, this is 5x. So there's an unknown. So you're multiplying by 5x and you got 0. So therefore, this is going to be part of your consideration using the zero product property. If it was just 5, you could just ignore it. But because it has the x, you have to use it. So that's one solution here. Another solution here. But when you come over here, you say, whoa, you see the square. What does the square mean? The square means it's 4x plus 1 times 4x plus 1. So it is duplicated. And you have to give account for that. So what should you do? You should rewrite this as because of the square, you see that it's this twice. So now you're going to get one solution here and one solution there. Just so you know, when you multiply this times this times this times this, it's actually going to be degree 4. So it's a quartic polynomial. And if it's degree 4, you must get 4 solutions. 1, 2, 3, 4. Not 3. If you give 3, you get partial credit. You have to realize, wait a minute, the square means twice. So that gives you an additional solution. Common mistake. A lot of people have given 3 answers, but it's actually 4 to get a perfect score. So now you go ahead and you solve. From here, we end up with 5x equal to 0. So therefore, x is equal to 0. That's your first solution. Come right here, 3 minus 2x equal to 0. Subtract 3 from both sides, so negative 2x equal to negative 3. Divide by negative 2, x equal to negative 3. Divided by negative 2, x equal to 3 over 2. That's your second solution. You get another you get a fraction. Over here, 4x plus 1 equal to 0. So therefore, 4x equal to negative 1. Divide by 4, x is equal to negative a quarter. And since this is the same as this, you know that this one gives you x is equal to negative a quarter. So what are the answers? 0, 3 over 2, negative a quarter, and negative a quarter. 4 answers, and 2 of them are identical. And that is okay. It is okay to have an identical solution or multiple solutions that are equivalent. I'll mention the word multiplicity in another session, but for today, I don't want to add anything new. I think we have done quite a bit today, and I'm very pleased. So I'm going to give you one last question, and then we call it a day. Let's go. Okay, so my trick question is, how many solutions does this equation have? How many solutions does that have? If you are following me and paying attention, you should be able to say to me, oh, okay, this 3 doesn't have an x, so it doesn't get affected by the zero product property because this cannot be 0. 3 is not 0. However, if you had 3x, then the x would have to be 0. So this gives me 1. This gives me 2. So 1 plus 2. And this gives me 3. So I get 1, 2, 3, 4, 5, 6 solutions. 6 solutions. Out of the 6, 2 are duplicated, and this is tripled. So what do we have? We have, from this, we end up with x is equal to 2. From this, we end up with 3x minus 2 equal to 0. So 3x equals to 2. So x equal to 2 over 3. And we're going to write that twice. So x equal to 2 over 3. Then x equal to 2 over 3. And then from here, we end up with x equal to 5. X equal to 5. X equal to 5. So let's go. X equal to 2. X equal to 2 over 3. X equal to 2 over 3. X equal to 5. X equal to 5 3 times. And I mentioned the word to you. It's called multiplicity. Multiplicity, new word to your vocabulary. Multiplicity is a word used when a solution is repeated in the same question. So how would you read that? You would say x is equal to 2, x is equal to 2 over 3 with multiplicity of 2. X is equal to 5 with multiplicity of 3. So you mention the word multiplicity and you give the number of repetitions. So it's 3, so with multiplicity of 3. It's twice with multiplicity of 2. So if ever you see that a solution x equal to 7 with multiplicity of 5, you know that 7 is repeated 5 times. So don't say I never taught you a new word. Multiplicity. And that comes in very quickly when we do zero product property. And again, I warn you, many students would have gotten lost because they would try to expand and get a degree 6 polynomial. Crazy. I can't even solve that myself. But once it's factorized, once it's set up as a product, boom, zero product property, boom, boom, boom. There are the answers. And you are now the expert. Thank you for tuning in. I hope this was helpful, and there's a lot more to come. Enjoy the rest of the day. On behalf of the Brosis Foundation, which is hosting these presentations, I hope that we'll continue to learn together.